Welcome to Getting Started with BIG-IP, the first in a series of web-based training courses designed to introduce you to the fundamentals of application delivery with a BIG-IP system. The overall goal of this course is to provide you with a basic understanding of how to set up, administer, and configure the BIG-IP system. This course also lays much of the groundwork for the other product-specific Getting Started WBTs. Therefore, we recommend you take both modules in this course before proceeding on to the other training in this series. Some network devices permit all traffic to pass through by default, and then are configured to restrict undesirable traffic. In contrast, the BIG-IP system is a default deny system. In other words, when you insert a new BIG-IP system into your network, any traffic that reaches it is denied to start with. This provides much tighter security, as you must then configure the system to specifically listen for and process application traffic. The BIG-IP system is based on full proxy architecture. Instead of having just a minimal understanding of the traffic flowing through it, BIG-IP completely understands the protocols and is itself an endpoint and an originator for those protocols, implementing them as both a client and a server. In other words, the connection between a client and BIG-IP is fully independent of the connection between BIG-IP and the server. This means the BIG-IP system can have its own TCP connection behavior, such as buffering, retransmits, and TCP options. The client-side connection can have different connection behavior than the server-side connection. In fact, the BIG-IP system allows for the optimization of every connection uniquely, regardless of the original source or the final destination. As a result of this architecture, the BIG-IP system can actively participate in the applications it delivers. For example, the BIG-IP system can accept IPv6 traffic from clients and then load balance that traffic to IPv4 application servers on the back end. BIG-IP can act as a centralized workhorse, offloading time-consuming and resource-intensive functions from the application servers, such as SSL encryption, compression, and caching. The system can be configured to inspect, modify, accept, or reject packets based on known and learned attack signatures. In short, the BIG-IP system alleviates the need to continually upgrade internal technology in response to rapidly changing external technology. The internal structure of the BIG-IP system is separated into two functional areas, one that's responsible for application delivery services, and another that's responsible for administrative functions. The core of the application delivery piece is the Traffic Management Operating System, or TMOS. TMOS is F5's real-time, event-driven operating system specifically designed for high-performance application traffic processing, custom-built from the ground up to support the variety of hardware components included in each system and to support virtualization. A set of independent modules runs on top of TMOS and can be configured to meet the performance, security, availability, and management needs of applications. For example, BIG-IP Local Traffic Manager, or LTM, can control network traffic that comes into or goes out of a local area network. It can intercept and redirect network traffic for the purpose of intelligently balancing the load on network servers. BIG-IP Access Policy Manager, or APM, provides policy-based, context-aware access to users while consolidating access infrastructure. And BIG-IP Application Security Manager, or ASM, provides Layer 7 firewall protection, keeping potentially vulnerable applications safe from attack without the need for costly application rewrites. Administrative functionality is supported by a separate aspect of the BIG-IP system that uses off-the-shelf components, starting with a Linux operating system. This administrative side of the Big IP system is not involved at all in application delivery. Instead, it provides the tools the administrator needs to configure and operate the Big IP system, including the command line, TMOS shell or TMSH, and the graphical user interface. Although the physical layout of Big IP devices varies from platform to platform, they all typically share some common features, including a management interface that provides administrative access to the Big IP system, USB ports for activities such as importing a hotfix or other file, a console port that provides administrative access to the Big IP system without the need for network configuration, a failover port for high availability or HA connectivity between two Big IP systems, indicator LEDs that indicate system or component status, an LCD display panel and associated control buttons that you can use to perform some management tasks without attaching a console or network cable, TMM switch interfaces. These vary in number, type, and performance from platform to platform, the serial number for the Big IP device. The TMM switch interfaces and the management interface both provide network connection entry points into the Big IP system. TMOS controls all of the TMM switch interfaces, while Linux controls the Big IP management interface. But while the TMM switch interfaces can process application and administrative traffic, the management interface is limited to administrative traffic. Here are some links to other reference materials related to this topic. These links point you to solution documents at askf5.com, and you'll find them throughout the Getting Started series courseware. You can stop this WBT at any time to click on a link and learn more. Now that you've seen the front panel, here's a look at a typical back panel on a Big IP application delivery controller. This view is from a Big IP 7000 series ADC. Shown are the fan tray, two AC power supplies, and a chassis ground lug. Some Big IP devices, such as the 5000 series, have just one power input panel. Others, like the Viprion 4800, have 4 power supplies. Using the LCD panel, you can manage the Big IP hardware unit without attaching a console or network cable. For example, you can use the LCD to configure the management port, reboot the Big IP system, power the unit on or off, or clear alarms. The LED lights to the left of the panel provide quick indicators of the overall operation of the Big IP device. Refer to your device's platform guide for information about how to interpret these LED indicators. The Big IP system offers both a graphical user interface and command line interface, so you can work in the environment where you're most comfortable, given the task at hand. The GUI is commonly referred to as the configuration utility in F5 documentation. The command line interface offers a subset of Linux bash commands when authorized, and the TMOS shell, commonly referred to as TMSH. Some configuration tasks are best performed or can only be performed with one tool over the other. For example, managing a Big IP APM access policy is far easier with the configuration utility than with TMSH, but you may decide that enabling or disabling a wide swath of pool members is more easily and quickly carried out using TMSH, especially since TMSH commands can be scripted. Over time, you'll almost certainly develop your own preferences. Access to Big IP system configuration tools can and should be restricted to avoid accidents or to prevent malicious activities. We'll talk about that a little more in the next lesson. To access the GUI, use your browser to securely connect to either the management IP address or to one of the Big IP system's self-IP addresses where such access is permitted. To access the CLI, use the console connection to the Big IP system or SSH to either the management IP address or to one of the self-IP addresses, again where such access is permitted. Let's take a brief look at a configuration utility screen so you can familiarize yourself with its layout. The navigation pane is on the far left, and the selections you see here will vary depending on the BIG-IP modules and features that are licensed and provisioned. You can click on any one of the selections to expand or collapse additional navigation elements. The breadcrumb area tells you where you are in the navigation hierarchy. In general, you can use the breadcrumb as you would on any GUI. For example, clicking on Pools Pool List on the screen shown here will take you up one level in the hierarchy to the list of pools defined on this BIG-IP system. The menu bar provides additional navigation selections and often includes pull-downs, as shown here. Status information is displayed in the upper left corner of the screen, to the right of the F5 logo. In general, green is good, yellow indicates a warning condition, and red indicates an error condition. These status indicators are more applicable when your BIG-IP system is part of an HA configuration. Clicking on the F5 logo from anywhere in the configuration utility will usually return you to the Welcome page. The Welcome page is the default home page for the configuration utility and contains links to many useful resources such as System Preferences, Ask F5, Dev Central, and the Setup utility. The body area is where you'll do most of the heavy lifting when it comes to system configuration. You can view context-sensitive help at any time by clicking the Help tab in the navigation pane. Finally, the bar across the top of the page provides information about the BIG-IP system, including its host name, the IP address you connected to, the current date and time, the user account you're logged onto, and your role. Your role determines in part what configuration tasks you can perform and on what resources, both for the configuration utility and the command line. For example, the administrator role has access to all resources and can perform all configuration functions, while the operator role can view all resources but can't modify them except to enable and disable. Throughout these Getting Started WBTs, we'll show you different parts of the configuration utility and command line using both video and interactive screens where you can try some of the navigation and configuration yourself. There are several steps that you must perform when setting up a BIG-IP system for the first time. These steps are similar across all BIG-IP platforms and all modules, and must be performed before the system can be configured to process application traffic. At a high level, the steps are as follows. Configure the management interface to provide administrator access to the BIG-IP system other than via the console. Activate the BIG-IP system by licensing, provisioning, and installing a device certificate, and configure platform-specific information, such as the host name, VLANs, self-IPs, and high availability information. You can perform these steps using either the CLI or the GUI, or a combination of both. To configure the management port, you can also use the LCD panel. In some cases, one tool may be more efficient than another. You'll walk through these steps in more detail in the next section. The first step in setting up your new BIG-IP system is to configure the management interface with an IP address, netmask, and optional default gateway. Several methods are available. You can connect a console to the BIG-IP system and use the command line. You can connect to the management port via its default configuration, or if you're working with an actual BIG-IP hardware system as opposed to a BIG-IP VE, you can use the device's LCD panel and control buttons. BIG-IP systems ship with the management port configured to the default IP address and netmask of 192.168.1.245/24, and with no default gateway specified. Why did F5 pick this particular IP address? Rumor has it it's because decimal 245 is equivalent to hexadecimal F5. If you can SSH to the management port at this default address, then you can configure it that way. If you do, keep in mind that the minute you change the management port's IP address, you'll probably lose your connection. The best option is to connect via the console. Your Big IP system comes preloaded with a base registration key that can be used to activate the license for your system. Licensing can be done via the command line or the GUI, depending on your preference. Either way, the method is similar. You start with the base registration key and use it to generate a dossier. You send the dossier to the F5 license server and use it to generate the license. You bring the license back to the Big IP system and install it into the appropriate location. If your Big IP system is connected to the Internet, this process can be done automatically at the touch of a button. It's more common, though, to perform this process manually, as this allows you to keep a copy of the dossier and license externally from the Big IP system for security reasons or for backup. Your license determines which software modules you may run on your Big IP system. Any licensed module can be run assuming there are available resources. The process of allocating resources, CPU, memory, and disk space to licensed software modules is called provisioning and gives you some control over the way the Big IP system will allocate available resources to each. Unlicensed modules can be provisioned, but their functionality is not active. Limited modules can be provisioned but have functional thresholds, including limits on traffic volume or number of users. To provision a licensed or limited module, click the checkbox next to the None option in the provisioning column, then select one of the available predefined resource levels, nominal, minimum, or dedicated on most systems. Nominal gives the module the minimum resources it needs to enable its functionality, and allocates additional resources to the module only if they're available after other modules are provisioned. This is the recommended setting under most typical circumstances. Minimum allocates only the amount of resources required for the module to be enabled. No additional resources are ever allocated. Dedicated specifies that this should be the only module provisioned on the system. If you select Dedicated for a module, the system resets all other modules' provisioning settings to None. This setting is primarily applicable for ASM and other modules installed in what's referred to as a standalone configuration. SSL certificates and keys are used on the Big IP system for a variety of purposes, such as administrative tasks, inter-system communication, and offloading SSL traffic. For administrative tasks and inter-system communication, the Big IP system uses a special certificate called the device certificate. The device certificate can be either a Big IP self-signed certificate, the default, or a CA-signed certificate that you import into the system. For authentication and communication between Big IP systems to work properly, F5 device certificates need to be stored in the correct location on each system, device certificates must be valid and current, and Big IP systems that are connected to a high availability configuration have unique device certificates that need to be maintained and renewed independently. After the Big IP system has been activated, you're now ready to begin configuration tasks. You typically start by configuring the Big IP platform's general properties and user administration settings. These steps are not unique to Big IP hardware devices. They are performed on Big IP VE systems as well. In the General Properties area, the current management port configuration is displayed and can be reset if desired. You can also configure the Big IP system to obtain its management port settings automatically using DHCP. Every Big IP system must have a host name that is a fully qualified domain name. Hostname is used for a variety of things, such as identifying Big IP systems to one another. Every Big IP system has a host IP address. The default is to use the same address as the management port, and this is generally adequate in most configurations. Use the time zone setting to specify the time zone region that most closely represents the geographical location of the Big IP system. Although this setting is important for proper time display for we humans, it's more important to ensure that the system time is set correctly to start with. The Big IP system uses two clocks to track time. The hardware clock tracks time even when the system is unplugged and is used to initialize the operating system clock when the system is booted. The operating system clock is a software clock that's available when the system is running. This clock stores time according to the local time zone that you configure here. Use the date command on the command line to set the hardware clock. Once the date and time have been set to a roughly accurate value, F5 recommends that you set up the Big IP system to keep its clock synchronized with an NTP server. NTP servers can be added to the Big IP system later using either the configuration utility or the command line. Big IP platform properties also include the credentials for the default administrative accounts and the IP addresses that will be allowed to access the management interface using SSH. The Big IP system ships with two default administrative accounts, root and admin. Account root has full command line access but no GUI access, and this cannot be changed. By default, account admin has access to all GUI functions but no command line access. You can change the admin account to provide command line access. Neither of these accounts can be deleted, and the root account is not present if you're running your Big IP device in appliance mode. Although you're not required to have any user accounts other than root and admin, F5 recommends that you create other accounts as a way to intelligently control administrative access to the Big IP system. F5 also recommends that you change all user passwords on a regular basis for security purposes. The Big IP system also includes support for using a remote authentication server such as Active Directory to store Big IP system user accounts and provide access control. This diagram shows a typical configuration that might be created if you use the setup utility to define your network components. As illustrated before, the TMM switch interfaces are the hardware ports that the Big IP system uses to send and receive application traffic. These are connected to your various switches, routers, and other network devices. A VLAN, or Virtual Local Area Network, is a logical subset of hosts on a local area network that operate in the same address space. You decide how many to configure, what address space they represent, and what interfaces will carry their traffic. If you use the setup utility to configure your new Big IP system, two VLANs are created, one called External for your conceptual external network, and one called Internal for your conceptual internal network. In your environment, this configuration may or may not meet your specific network needs. If so, you can configure these network components yourself using the configuration utility rather than the setup utility. A self-IP address is an IP address on the Big IP system that you associate with a VLAN to access hosts on that VLAN. By virtue of its net mask, a self-IP address represents an address space, or in other words, a range of IP addresses spanning the hosts in the VLAN rather than a single host address. There are two types of self-IP addresses that you can create. A static or non-floating self-IP address is an IP address that the Big IP system does not share with another Big IP system. A floating self-IP address is an IP address that Big IP systems in a high availability device group share. For each self-IP address that you create for a VLAN, the Big IP system automatically assigns a MAC address. In addition to setting up your Big IP system on the network, you can also group your Big IP systems with one or more other Big IP systems for the purposes of failing over in the event of an outage. High availability and device service clustering is explored in more detail in the Getting Started with LTM course. NTP is a protocol for synchronizing the clocks of computer systems over the network. On Big IP systems, accurate timestamps are essential to guarantee the correct behavior of a number of features. For example, Big IP device groups and Big IP DNS sync groups rely heavily on accurate system clocks to successfully synchronize configuration data between members.
Therefore, it's essential that all big IP systems that are interconnected synchronize their system clocks to a common NTP service. To add an NTP server to a big IP system's time server list, you simply specify its IP address or fully qualified domain name. The server can reside in your network, or you can point to a public NTP service. Note that if you want to specify an NTP server by its FQDN, you will need to configure the big IP system's DNS settings first. And if you want to access a public NTP service, your big IP system must already be able to access the Internet. There may be situations when you want the big IP system to use DNS to resolve hostnames defined within its configuration. For example, you might want to add an NTP server using its domain name rather than its IP address. Or consider this scenario. In support of application delivery, you can create a pool with members that are identified with a fully qualified domain name instead of IP addresses, and have the big IP system use DNS to auto-populate the pool's members using the IP addresses returned in the DNS response. The name servers the big IP system queries are defined in the system's DNS lookup server list, and you can add the IP addresses of whatever name servers you would like the system to use during or after setup.
Now for some action. The next series of videos will walk you through an example of accessing the big IP system and then activating and configuring it using the setup utility. There are several methods that you can use to configure the management interface on your big IP system. One of the easiest is to simply connect a serial console to your big IP device, or if configuring a big IP VE, to use the hypervisor's console support, as we're doing here. On a brand new big IP system, only one default user account has command line access. Its username is root, and the password is default. You're now sitting at the Linux bash prompt, and more specifically in the config directory. Enter the command config. The first in a series of panels that walk you through the configuration process displays. You can use the Tab key to navigate between fields and selection options, and the left and right arrows to navigate within fields. On the Configuration Utility panel, click OK to begin the configuration process. On the Configure IP Address panel, note the default settings for the management IP address, netmask, and default route, as we described earlier in this lesson. When prompted to use automatic configuration of the big IP address, select No to manually configure instead. On the Configure IP Address panel, enter the appropriate IP address for the management port, tab to the OK field, and press the Enter key. On the Configure NetMask panel, enter the appropriate netmask value for the management interface, then select OK to continue. Here we're using a netmask of 16. The Management Route panel allows you to create a default route for the management port. A default route is only required if you want to connect to the management port from another subnet. In this example, we're not going to configure a default route, so we'll select No and continue on. The last step in the process is to confirm your settings. On the Confirm Configuration panel, if the settings are to your satisfaction, click Yes to save them. Otherwise, select No to exit the utility without saving changes. You can display the current management interface settings from the command line using the tmsh list sys management-ip command, as shown here. Now that the management interface is configured, you can access the GUI with your web browser and continue the setup process. To access the configuration utility, open a secure browser session to the management port's IP address. The Big IP system ships with a default self-signed certificate that may trigger a browser alert. Accept the certificate to continue. Log in with the admin user's credentials. Both username and password are admin. On a new Big IP system, we're automatically taken to the Setup utility, where we'll click the Next button to begin. The first thing we need to do is activate the license. Notice that the base registration key for your Big IP system is already pre-populated in the GUI. Since our Big IP system has no direct connection to the Internet, we will perform the licensing process manually. A dossier is created using the base registration key. We'll use the copy-paste text method to get the dossier to the F5 license server. If you wanted to save a copy of the dossier and license outside of your Big IP system, you could use the download-upload method instead. We'll select everything in the dossier field and copy it to our clipboard. Now we'll connect to the F5 license server at license.f5.com and click on the Activate License link to start the process. We'll paste the dossier from our clipboard into the field provided. The license is generated and displayed in a scrolling text box. We'll select everything in the text box and copy it to our clipboard. Back on the Big IP system, we'll paste the license from our clipboard into the field provided and click the Next button to complete license verification and activation. This can take a few moments. We're now at the provisioning step. Here you can see current CPU, disk, and memory resource allocations, as well as all the modules we're licensed for. By default, LTM is nominally provisioned. We'll provision both LTM and GTM, setting nominal for both, then continue the Setup utility. Reprovisioning may restart certain Big IP processes, called daemons, or may even reboot the system. After the restart completes, we'll continue to the next step in the Setup utility. On this step, you could import an SSL certificate onto your Big IP system. We'll continue to use the default self-signed certificate for now and click the Next button to continue. On the platform screen, we'll provide a hostname for this Big IP system and change the root and admin users' passwords. In doing so, we'll be required to log back in again. We've now completed the activation phase of Big IP initial setup. From here, we can either continue with a standard network configuration or finish with the Setup utility and create a more advanced network configuration manually. We'll continue and create what's referred to in F5 documentation as a standard network configuration. The Redundant Device Wizard Options screen allows us to select whether or not we wish to prepare our Big IP system to participate in a high availability or HA configuration. The selections we make here will determine some of the later Setup utility options. We'll go ahead and get ready for HA by ensuring that the options are checked. The standard network configuration creates two application delivery VLANs, one called internal and the other called external. If you need more than just these two VLANs, you would not use the Setup utility, but rather configure the VLANs using the configuration utility. Two application delivery VLANs are sufficient for our test purposes here. We'll create VLAN internal as the 172.16/16 network on interface 1.2. The static self IP address and netmask define the network, and the floating self-IP addresses required for HA. We'll also create VLAN external as the 10.10/16 network on interface 1.1. Since we requested HA options, we have to specify the VLAN that will be used for HA communication. We could create a third VLAN, which the setup utility will name HA, or use an existing VLAN. For our test purposes, we can use the existing VLAN named internal.
On the NTP screen, we will set up the BIG-IP system to synchronize its clock with an NTP server at 172.16.20.20. The setup utility also provides options for configuring DNS services to resolve hostnames in your configuration. In this example, we will add a DNS lookup server to the BIG-IP configuration. This will enable the BIG-IP system to use fully qualified domain names to identify network objects, such as nodes.
The remaining steps are a continuation of HA preparation. For now, we'll take all the defaults and refer you to the Getting Started with LTM course that will be used for HA communication. We could create a third VLAN, which the setup utility will name HA, or use an existing VLAN. For our test purposes, we can use the existing VLAN named internal.
On the NTP screen, we will set up the BIG-IP system to synchronize its clock with an NTP server at 172.16.20.20. The setup utility also provides options for configuring DNS services to resolve hostnames in your configuration. In this example, we will add a DNS lookup server to the BIG-IP configuration. This will enable the BIG-IP system to use fully qualified domain names to identify network objects, such as nodes.
The remaining steps are a continuation of HA preparation. For now, we'll take all the defaults and refer you to the Getting Started with LTM course for an explanation of what these settings mean. We'll click Next to take the defaults for Config Sync configuration. We'll click Next to take the defaults for failover configuration. And lastly, we'll click Next to take the defaults for mirroring configuration. We've now reached the second milestone in the setup utility. At this point, we could go on to set up an active standby pair. Again, for now, we'll just finish and refer you to the Getting Started with LTM course for a good presentation on this topic. The BIG-IP system is now ready to configure for application delivery. Once you have created configuration data on your BIG-IP system, you can replicate most of this data into a separate file for backup or as a way to propagate configuration data to other BIG-IP systems. For example, before installing an upgrade or a hotfix, or making significant changes, you should create a backup copy of the current configuration in the form of a user configuration set or UCS file. A UCS is a compressed file that contains all of the data required to restore a BIG-IP system to a prior configuration, including BIG-IP configuration files, BIG-IP product licenses, local user accounts and passwords, SSL certificate and key pairs, and DNS zone files and zone runner configuration on GTM systems. You can override some of these settings at the time you create the UCS, and you can also customize the files that are included in a UCS. You can use either the configuration utility or TMSH to create a UCS. In this example, we're using the TMSH save sys UCS command to create a UCS called train1 base.ucs. By default, the Big IP system will save the file with a .ucs extension and store it in the directory var local UCS. UCS files that are in this directory are visible on the configuration utility. After you create a UCS file, you can archive it in a secure location. The default UCS file contains SSL private keys, user accounts and passwords, and critical system files. Archiving in a secure remote location provides an extra level of protection, and it frees up space on your Big IP hard drive. F5 recommends archiving your Big IP system's configuration regularly for safekeeping, problem diagnosis, and disaster recovery purposes. When you restore a configuration from a UCS file using either TMSH or the configuration utility, the Big IP system automatically creates a rotating backup of the current configuration first, saving it to csbackup.ucs. The number of files in this rotation is controlled by the settings in csbackuprotate.conf. Once the next backup rotation UCS is created, the Big IP system replaces the stored configuration on its hard drive with the extracted contents of the UCS file and then loads that new configuration into memory for operation. A reboot may be required after the restore. Here's an opportunity for you to simulate the steps involved in creating a UCS file, downloading it to your desktop for archiving off-site, and later restoring the Big IP configuration from the UCS file. Instructions are provided on the left side of the screen, narration is provided when appropriate, and hint arrows will appear after a short bit to help guide you. You'll also find a couple of icon buttons in the lower left corner of each screen that you can use to restart the exercise or to skip to the end of the exercise. Let's start the exercise by using the configuration utility to create a UCS archive. In the navigation pane, select the System module. If you're not sure how to do this, a hint will be provided for you in a moment. Your UCS file has been created and is shown in the Let's start the exercise by using the configuration utility to create a UCS archive. In the navigation pane, select the System module. If you're not sure how to do this, a hint will be provided for you in a moment. Your UCS file has been created and is shown in the archive list. Now let's simulate the process of downloading the UCS to your desktop. Start by selecting the UCS you just created. Now let's simulate restoring the Big IP system from a UCS file using the configuration utility. If the UCS is not already on the Big IP system and in the var local UCS folder, you could use the configuration utility to upload the UCS from your desktop. Let's restore this Big IP system's configuration from train1 base.ucs. Since we encrypted the UCS when we created it, we're required to provide the passphrase on restoration. Click in the Restore Passphrase field and we'll fill it in for you. Now restore the configuration. It's best to wait for the restore status to display before clicking the OK button. That way you can observe any messages the system generates during the restoration. Now that your UCS archive has been restored, navigate back to the archives list using the breadcrumb to see what's changed. Notice the new rotating backup appears in the list. csbackup.ucs contains the configuration as it looked immediately prior to restoring from train1 base UCS. Want to learn more? The second module in this course will introduce you to the basics of Big IP configuration for application delivery, and the instructor-led course entitled Administering Big IP provides much more detail on the topics presented in this module. Thank you for taking this course. You're now ready to move on to Getting Started with Big IP Module 2 Application Delivery. And don't forget to check out the product-specific Getting Started courses, as well as all the instructor-led training curriculum available from F5 Global Training Services.